What we'll cover in this section is the slight configuration changes in the middleware that you have already deployed. What we want to cover today is how do you deploy the middleware by yourself, so you know what exact configuration do we support with our 5G era middleware. So let me just log into the virtual machine. Remember, the password is ROS2023. And as you already know, the virtual machine comes with the middleware already deployed. But the deployment of the middleware that you can see in here is, let's say, not the version that you want to use. The version that you have is the current edge of the development. It is not the stable version, so we may experience some problems while using it. So to do so, what we are gonna do is we are gonna redeploy the middleware, and I'll explain the whole process for you, so you will be able to follow along and repeat it later on your own. So what I would recommend is to open up two terminal windows side by side. On one of the terminal windows, I highly recommend running the kubectl get all -n middleware to get the list of the currently deployed services in the Kubernetes cluster in the middleware namespace. Our whole middleware runs in this namespace, so it is easily segregated and doesn't affect the other applications running in the rest of the cluster. But as we want to constantly see what is going on with this cluster, I would highly recommend running the command starting with watch -c and then the rest, kubectl get all -n middleware. Thanks to this, every 2 seconds we will get an update of what is going on. In the second terminal window, if you will get to the home directory, you will see that there is a middleware folder inside. We want to enter it, and then in the middleware there is a K8s folder that contains the Kubernetes utility scripts for the middleware, and then in the orchestrator folder there is a set of utility scripts and middleware deployment configurations. We'll be using this today, so if you could please go to the middleware, K8s, and then the orchestrator. As you can see, we've got a few scripts. The most important ones for us are delete all to automatically delete the middleware, deploy.sh to deploy the middleware, and then the orchestrator.yaml, which contains the configuration of the orchestrator, which will deploy the whole middleware for us. So to have a fresh start, what we will do is actually we're going to delete the middleware. So for this, we'll call the script delete all sh. Is everyone following me? I will take the silence as a yes. Okay, so let's go ahead and delete everything. And on the right-hand side, you can see that all of the services from the middleware namespace have been deleted. So now let's go on and let's go over the configuration of the middleware deployment. So for this, we are going to go with open the orchestrator.yaml file. You can do this with whatever editor you prefer. For this, I will use Vim, but you can use Nano or whichever editor you have. You can even use VS Code as we have installed it in the morning session. As you can see at the moment, this file contains of two Kubernetes object definition. The first one is the service that will expose the orchestrator API within the cluster and within the middleware namespace. We are exposing two ports, port 80 and 443. And later on, we have a definition of the deployment that will actually deploy the middleware for us. The most notable things in here are in the specs, in the containers definition, the image that we are using publicly available 5Jira orchestrator image. Yes, Michal?
Yes, I have a question. If I don't use the virtual machine, where can I find these files?
So to get these files, you have to clone the middleware repository.
Okay, I'm just looking it
Okay,
and I don't see.
You've got a K8S folder in here.
Yes.
Then orchestrator.
Yes, but okay. I see. Okay. For some reason, it did not. Okay, that's some problem in my side. Thank you. Thank you.
Okay, no worries. So if anyone has questions, John, please go ahead, raise your hand, and we'll try to explain everything as we go. Okay. So now, the three most important things are the image that we will be using and the repository. We will be using ghcr.io, which is the GitHub container registry. Under the 5Jira repository, there is an orchestrator API image. We'll be using tag latest. At the moment, what you have in your configurations is the tag edge. We want to change it to the latest or to the version 0.4, like this. This is the current latest version of the middleware, which we highly recommend to use. Going further, there are some environment variables that we'll have to configure. First one is the image registry, which should have the same value as the image that we have now in here, because this is used by the orchestrator to deploy the rest of the images in case we would like to use a different container image registry. Next will be the Redis interface API service host and Redis interface API service port. These environment variables are here held from the backwards compatibility reasons. In the latest version, they are not needed, so we don't have to worry about them. The next three environment variables will be the middleware organization, middleware instance name, and middleware instance type. So these three environment variables allow us to define what middleware we are using. As the middleware is a distributed system, it allows multiple of its own instances to communicate between each other to support the better deployment solutions, the better deployment placement for the vertical applications, and there's a need to recognize which middleware is available for us within some boundaries. So the first concept that we'll have in here is the middleware organization. The middleware organization is an artificial group of the middlewares that can work with each other. So in here, we'll be specifying the name 5Jira dev. You can specify something else if you would like. Just have in mind that for middlewares to be able to work with each other, they have to be within the same organization. Next is the middleware instance name. The middleware instance name has to be unique within an organization. for us to work. This name will be used to specify where do we want to deploy some applications, and so we will know where the applications are deployed for in the later stages of this hackathon. And then we have the instance type. Usually we'll be specifying this as an edge device, or we can specify this in a bigger data center as a cloud value. This is used mostly for the segregation purposes, to know which instance is responsible for what. Is responsible for what. The central API host name is the host name of the central API, an additional API that we'll be using to recognize in which organization we are. This central API will allow us to make our newly deployed middleware available for the other middlewares to be used. And also it will keep the track of the currently registered and available instances. In the end, we've got some environment variables for our AWS secret manager, so we don't have to specify all the configuration parameters by ourselves. And in the future releases, we'll give you the possibility to specify them manually in here to achieve the greater more possible configurations, and the middleware to be later on more easily reused. After this hackathon, these AWS access keys will not be working anymore, so you don't have to worry about those keys leaking somewhere else. Okay, when we have this configuration adjusted to our needs, we can close this file, just save and close. And then what we can do is we'll call the deploy script, deploy.sh. So what will happen after we do so is the orchestrator is being automatically deployed. And in a few seconds, as you can see, it starts to create the rest of the middleware services. Now, as the other services are being deployed, in your case, it may take a bit longer, as it will be the first time pulling this image. We should see that the gateway service has its external IP address assigned. To actually verify that the yes, Michal, I'll share the values with you in a second. Just to verify that everything is working, we'll go to the web browser, we'll paste this IP address, and we should see the welcome banner of the 5G era middleware. Okay, I'm going to give you a bit of time to catch up, and in the meanwhile, I'm going to copy these values for Michal. So I'm going to paste them in a chat. And then the last one. AWS secret access key. Okay, you're welcome, Michal. Do everyone else is following us? Do you need some further explanation on the some topics that we have done in here? And I hope that everyone has its middleware up and running in the latest version. To confirm that we are actually running the latest version, what we can do is we can, for example, say that we'll query the Kubernetes to describe some deployments for us. For this, we'll use kubectl describe deployment and the name gateway. So not the orchestrator API that we have deployed, but some other service. And then we'll just specify the namespace to use -m middleware. And now, as you can see, we are using the same image with the same tag that we have deployed the orchestrator. So which means that the middleware is deployed with the latest up-to-date version. Have you managed to deploy the middleware, Michał?
Yes, thank you.
Okay, that's great. And does anyone have any questions? This will be it from me. I think that we can move forward with the rest of preparing the environment.
Good. We are very good on timing, so we have 4 minutes left for your session, and so you do the demonstration for everyone on this part. And if we see the same result, it means that we are ready for tomorrow.
Yes, exactly. We are ready for tomorrow. We'll be ready to deploy the network applications and to onboard all the pieces of the middleware.
Okay. If this is all clear, we will proceed to the next part, preparing and testing the network applications in the Fedora environment.
Okay, thank you.
And the next part is by Michał.
Okay, for this session, I will mainly show you the task which we will be solving tomorrow, and we will go through it, and maybe we can, we can take a look on the task. So let me share my screen. I hope I will pick the right one. Okay, can you see the terminals?
Yeah. Yes, we can.
Okay, perfect. So for tomorrow's task, we will use the simulation of the TurtleBot, which we were preparing in the morning session. So I will run it now. So as you can see, as you can see, it's running now. So it's a good idea for you to try it on your computers. And in tomorrow's tasks, the main task will be to drive the robot around using some pre-prepared ROS node, and we can take a look on this node. Find the correct terminal. Yeah, you can see in the repository, I sent you the link in the morning session. You can find the obstacle avoidance ROS2 node. which contains one node, package, which contains one node. It's called detector node. And this node or this application contains two nodes. One of them is the driver node, which is quite simple. It reads the information about the nearest obstacles in front of it. And if the nearest object in front of the robot is closer than some threshold, for example 20 centimeters in this case, then the robot, if there is no such object, the robot goes forward with some speed. And if there is some object, the robot starts rotating to find a free way. We can try to run it. And you can see that the robot goes forward and it prints into the terminal the distance to the nearest object. It's quite slow. Come on. Now we can see just the wall. Oh, sorry for this. I'm not really familiar with this simulator, and I'm not sure how to control the view. I will probably stop the robot before I can find it.
To move the camera, you have to use a right button mouse.
Okay.
And you can use the scroll button to alter the angle of the camera.
Okay. Yeah. Oh man, I was able to do it yesterday. I'm not sure why I'm not able to move it today.
You are just a matter of graphical user interface. So.
Yeah. Okay. It looks better. So okay, I will run the node again, and you can see it goes forward. And once the distance is lower than 0.20, it starts rotating and looking for a freeway. I'm pretty sure it was faster yesterday. I'm not sure what happened today. And it's not running on the virtual machine, but okay, no worries. So this will be your task for tomorrow to actually change this this ROS package to use the computation on the network application, because I showed you the first node, which is responsible for driving the vehicle, but there is also a second node, which is responsible for reading the data from laser scanner. And there is a, I call it core algorithm, which goes through the data in this laser scanner, and it will select only the fraction of the data in front of the robot of some angle, which is defined by some user parameter, and it will find the minimum distance, so the closest object. So this is the algorithm which goes through the data, and and the result of this algorithm is the closest object. And your task will be to move this computation out to the network application. That will be the task for tomorrow's morning session. And in the afternoon session, you will upload this network application to the cloud, and you will put here in this node the client library, which will deploy the network application, and it will start to communicate it, and it will be sending the data to the network application, receiving the results, and publishing it back to the robot. So I can show you how it will looks like. I think I should have prepared this application somewhere. Okay. I don't have. I have it on another computer, but don't worry, it would look exactly the same. But the results will be the same, but the data will flow through the network application. So for today's, to be prepared for tomorrow, you should be able to run this simulation and run this obstacle avoidance node. So the robot is moving around like you can see here. So if you have this working, you are prepared for tomorrow.
Great, I have it working.
So please try to make it work, everybody, and feel free to ask any questions. If it does not work, we can take a look on it. And yeah, that's it from me.